Hi everyone, Logistics Fan here. Today we're revisiting containerization, how it works, why it matters, and what's changed since Docker first popularized the idea. Whether you're new to containers or looking to modernize your platform, this video will give you a 2025 ready overview. Containerization packages your application code together with only the OS libraries, dependencies, and configurations it needs into a single, lightweight executable, the container image. Unlike virtual machines, containers share the host OS kernel, making them far more portable and resource efficient. 2008 Linux introduced control groups or CE groups in kernel 2.6.24, enabling resource isolation at the process level. 2013 to 2015, Docker surged in popularity, but competing runtimes like RKT and LXC led to fragmentation. June 2015, Docker, CoreOS, and others formed the Open Container Initiative, or OCI, to standardize container image and runtime specs. 2017, Docker spun out its core runtime into Containered, now a graduated CNCF project and industry-standard runtime. 2018 to 2020, adoption of rootless, daemonless engines like Podman for security and system integration. 2020s, Kubernetes became the de facto orchestration layer, and service meshes like Istio graduated from CNCF to handle microservice networking and security. VMs, host OS plus hypervisor plus guest OS plus libraries, heavy footprint around 400 megabytes plus for node.js. Each instance bundles a full guest OS, leading to duplicated overhead and slower boot times. Containers, host OS plus runtime engine, for example, Docker engine, Containered or CRIO, tiny footprint. Images often under 15 megabytes for a node.js app using multi-stage builds and Alpine or distroless bases. Shared kernel and layered file system means faster startup and higher density. Define a manifest, for example, a Docker file following OCI image spec or Kubernetes YML. Build the image using a builder, Docker CLI builder or Podman build to produce an OCI compliant image. Push to an OCI registry Docker Hub, Azure Container Registry Harbor, and deploy via Containered/CRIO on your Kubernetes cluster or directly on Fargate Azure container instances. Lightweight no guest OS duplication. You can run dozens of node.js, Python, or Go containers on the same host that previously held only a handful of VMs. Elastic Kubernetes horizontal pod autoscaler can spin up additional container replicas in seconds, sharing idle CPU and memory. Multi-service. Separate each microservice into its own container. Scale the node.js frontend independently from a Python image recognition sidecar without re-provisioning an entire VM. Rootless containers. Tools like Podman run unprivileged containers by default, reducing attack surface. Image scanning and signing. Integrate scanners. Claire, Trivy in your CI/CD pipeline and sign images with Grapheus or Notary. Minimal base images. Use distroless or scratch images to strip away unnecessary components. Supply chain integrity. Adopt OCI distribution, spec compliance, and verify image provenance. Network policy. Enforce zero-trust networking with service meshes like Istio, traffic encryption, MTLS, and fine-grained access rules out of the box. Kubernetes automates container scheduling, health checks, and rolling updates, now ubiquitously offered by all major cloud providers. Istio, version 1.25 and later, provides advanced traffic management, A/B testing, canary releases, observability metrics, distributed tracing via Jaeger, and zero-trust security with ambient mode sidecar-less deployments. WebAssembly or WASM containers ultralight. VM-like isolation for specific workloads. Serverless containers, event-driven container execution without dedicated nodes, for example, native. GPU inference at edge container runtimes optimized for AI and machine learning at the network edge. Policy as code. Enforcing security and compliance through programmable policies, for example, OPA gatekeeper. Cloud-native supply chains, standardized metadata for provenance, vulnerability, and SBOM integration. By understanding these foundations, C groups and namespaces from 2008, the rise of OCI standards in 2015, the evolution of runtimes like Containered and Podman and modern orchestration and security practices, you'll be ready to leverage containers effectively in 2025 and beyond.